All right, guys, we're going to jump into lesson 7.2 and our focus lesson here. Our I can statement is that we should be able to write and interpret inequalities again here and graph solution sets, kind of like we were doing yesterday, but we're going to do them in more real-world situations. Okay, and some of the stuff we're going to talk about, we'll talk about multiple ways to think about things today and do some of this. So be paying close attention. This can be kind of a tough lesson here. Okay, so just wanted to introduce you to the situation that we're dealing with here. At the grocery store, it's got a salad bar, and the price of the salad bar is determined by its weight in pounds. However much food you take and it weighs is how much you pay. You can also buy these items separately at the grocery store, and this chart tells me the cost of what they would cost if you buy them separately. And you can see bacon bits, very expensive here. It's $21.28 a pound. Very expensive. This kind of cheese is very expensive. And then you got some cheaper things too. But obviously, if you're going to buy them at the store and buy a full pound of just bacon bits, it'd be a lot more expensive. And again, you could think about this. If you go to a salad bar and it only costs $7 or $8, you could technically load it all up with bacon bits because they're so expensive, and you'd be kind of robbing that store a little bit because they're only charging $6 or $7 for the salad, and you're getting $21.28 worth if you get all bacon bits. But of course, when you get a salad, you're probably not gonna do that because you're gonna have to get a little bit of lettuce and other things to put on there. Okay, so they're trying to decide how much to charge per pound for their salad bar here, and RC suggests charging at least $3.99. So I'd like to define a variable and write an inequality to represent here. For example, we could call the variable whatever we wanted, but we could just say like P for price. You can talk about P being the price, and it has to be at least. So with those inequalities, that means it has to be greater than or equal to $3.99. Okay, that would be our inequality in this situation. It has to be greater than or equal to $3.99, according to his suggestion. Okay, which means you could charge more than that. Okay, if you only charge $3.99, for example, down here, explain why you think his price is reasonable. Is it too high or too low? Well, if you charge $3.99, it's going to be too low. All right, you would lose money. There's a lot of things up here that cost more than $3.99. So if you start piling a lot of that onto your salad, they would actually be losing money. So they would charge a little bit more than that. And again, I'm not going to write all that down, but I would say that's a little bit too low for the price. They're going to set it higher, you're going to see here in a minute. Okay. All right, so we're going to go down and look at a problem that you're going to have to be able to do, and we'll talk about several ways to think about it. Okay. So in this first situation, I know that light's in the way a little bit here, but Archie and Natalie decide to charge $7.99 per pound for the salad bar. And we're going to compare those costs a little bit, and we're going to be able to try to represent these situations with inequalities. Okay, so we'll just kind of follow through this set here and talk about how to think about some of these things. First question here. How many pounds of bacon bits, so we're looking at the bacon bits, sold separately, not buying them from the salad bar, but if they're sold separately, like from the store, how much could you buy for up to $6? Okay, and if I'm not going to roll back up to that chart, but if you remember in the chart, the bacon bits cost $21.28 a pound. $21.28 a pound. We're only going to spend, we want to know how much we could buy for up to $6, or that means $6 or less, thinking about our inequalities. Okay, so how much could we buy for that? We're going to try and graph this situation. So record the solution set for X. Okay, and in this case, they tell us X is the number of pounds. Okay, they're going to tell us that right here. So that's our variable. X is the number of pounds. And we're going to record and graph the solution set to the nearest hundredth. We're going to have to round a little bit here. Okay, so the solution set, if we're looking through here, we know we're going to have to do a little bit of math. But the first thing we know is, first of all, we're going to have more than 0 pounds. Okay, you can't have negative pounds, and it can't be exactly 0. So we know X, at some point, we know that it's going to be greater than 0. Okay, remember, X is the number of pounds of bacon bits. It has to be greater than 0. You can't have negative or 0 bacon bits when you go to buy them. So this is going to be, there's two situations going on here. Okay, and we can combine that into a double inequality or a compound inequality later if we need to. Okay, but the hard part is, we're trying to figure out how many pounds of bacon bits they can buy. They only have $6. And 1 pound costs $21.28. So we know they can't even get close to a pound. All right, they only have up to $6 out of $21.28 for a pound. So one way that my brain sees this, and I'll go do a little work up here, I have $6 out of the total. If I'm comparing to a pound, I've got $6 out of $21.28. It's kind of like, think of a test score. If you got 6 questions right out of the total, all right, you could figure your percent or figure what that is as a decimal. Okay, so when I'm looking here, I know this means divide. I could actually just take 6 divided by 21.28. And if I take 6 divided by 21.28, you're going to get something like 0.28. Let me look here, 195, and it keeps going. All right, and it said to round to the nearest hundredth. So I would just look here, the tenths, the hundredths, and I look back to the 1. I'm not going to round it up. So approximately, just looking at it that way, I can buy, I can get a 28 hundredths of a pound is what this is telling me. 28 hundredths of a pound of bacon bits for $6. Okay, so my second inequality would be X has to be less than 0.around 28 hundredths of a pound, because we know X, it has to be less than 28 hundredths, or it could be equal to it. All right, so X, your pounds you can get have to be less than or equal to 28 hundredths, which makes sense. I can't even get close to a half of a pound because we don't have half of $21. Okay, so it should be less than that, so this answer makes sense. Okay, there's other ways to think about this. Sometimes you can set up a proportion. A lot of your parents, maybe if you were asking about this, they would try and set up a proportion. So this is something you could write down. Again, pause the video if you need to, if you're watching this. But that's one way I see it and think about it. It's like a part to the total, all right, when you're thinking about things. And this would be about 28%, right? 28 hundredths. So you can get about 28% of a pound or 28 hundredths. Okay. All right, another way to think about it, if you're setting up a proportion, a lot of ways you were told you can compare like pounds to cost. So you can make it look like a fraction. Again, this is the ratio stuff we talked about. We could say 1 pound costs $21.28. So here's my pounds, and I'm comparing it to total cost. So think of this like a ratio. 1 pound is $21.28. And setting that up proportion, that's got to equal, well, we don't know how many pounds, so we're going to call that X. Remember, pounds is on the top. And how many pounds can you get for $6? Okay, so 1 pound is $21.28. So X pounds is $6. So we're trying to figure out what X is. So there's lots of ways to think about this. Okay, we'll talk about what your parents would probably tell you and setting up a proportion and solving with algebra. But we also know, guys, whatever I do to the bottom, I must do to the top to get down to 6. So if I have a calculator here, I can think 21.28, what do I divide it by to get down to 6? And whatever I divide that by, I must do the same to the top to keep it equivalent. Okay, so if you just take 21.28 divided by 6, it'll tell you the difference between there. And if you do that, you're going to get 3.54 something. So we'll just round it off to 3.54. So really, I could take, sorry, kind of hard to read there, 21.28 there, divide it by 3.54, and that gets me down to 6. And we know whatever I do to the bottom, I must do to the top. Okay, so I must divide that by 3.54. All right, because then you're just dividing by 1, and anything divided by 1 is itself, it'll keep it equivalent. And if you take 1 divided by 3.54, you will also get 0.28 something, which again will be round off to 0.28. So when you look at this as a proportion, remember, I'm going to erase this here because we set these equal to each other. Okay, if 1 pound costs $21.28, then 0.28 pounds costs $6. And it makes sense. This should be less. This is 3.54 times smaller, so this has to be 3.54 times smaller. And again, I still get up to about 28 hundredths. So you could buy up to 28 hundredths of a pound. Now, what your parents would probably tell you to do, and some of the old traditional ways to do this with algebra, which we've learned and we can use that to help us now, if we set them equal to each other, guys, we can cross multiply and say this times this must equal this times this. A lot of times you'll see people draw arrows, to remind you to do that. Since both sides are equal, you can do this and it will always work. So 21.28 times x is 21.28 times x. I just write an x, right? And that must equal $21.28 times 1 is just 21.28. All right, so now we're going to solve for x because that's what we want to know. So this is 21.28 times x. If I multiplied it by 21.28, remember how to undo that with inverse operations, we would then divide by 21.28. Okay, if I multiply it and then divide it, it undoes it, leaves x by itself, and what I do to one side, I must do to the other. So both sides I divide, so what I get here, when I divide this, I get 21.28, and double check I did this right. Oh, sorry, here's where I messed up. Sorry, this should be x over 6. Sorry, I got in a little bit of a hurry there. Okay, so when I cross, this should just be 6. Okay, so 21.28 times x is 21.28 times x, written like that, and 6 times 1 is 6. So again, I set them equal to each other, and sorry about that mistake there, guys. And if I divide this by 21.28 to undo it and isolate my variable, I must take 6 divided by 21.28. And that actually just turns out to what we had the very first way I showed you. Sorry, I'm going over your writing here, but if I divide that, you get x equals 0.28 something when you round it off to 0.28. All right, so it kind of ends up like at the first time we said we have 6 out of 21.28. This proportion ends up getting you that, okay, and that's why that process works when you cross multiply there, okay. So we're supposed to record the inequalities. They wanted the solution set here. I kind of already did the inequalities here, but I'll get that here in a second. But to record the inequalities, we would say here x has to be less than or equal to 28 cents. Let's do the inequalities. I'll move it down here. 28 hundredths. X is less than or equal to 28 hundredths. And at the same time, remember, x has to be greater than 0 because you can't buy 0 or negative pounds of something. Okay. The set, I didn't do the set notation. I kind of got ahead of myself there. The solution set, again, we'd explain in numbers. We know there's infinite answers here. We would be talking about all numbers less than or equal to 28 hundredths. All numbers less than or equal to 28 hundredths. All right, they have to be less than or equal to that. And then at the same time, they have to be greater than 0. And I've got my braces there to let me know it's a solution set. And now all I need to be able to do is graph that. All right, so I got to find 28 hundredths, which would be on my number line here, close to 30 hundredths, so about here. Okay, and it has to be less than or equal to that, so I can just shade in the circle because it can equal that exactly. And I know it has to be greater than 0 because I need to buy greater than 0 pounds or I'm not buying anything. And anything in here I could afford for $6. Okay, but the most I could get is 28 hundredths of a pound. And then anything in between there are things that you could buy for up to $6. So again, a lot of work there, very complex, a lot of different ways to think about these things, and just want you to get very, be able to think deeply about how we're coming up with this number of 28 hundredths, because it's kind of difficult. And on question 3, when we do a practice one here, we're going to change the situation a little, and this is what we're going to be expected to be able to do. Okay? All right.